Example 1 is on page 353 of your textbook. It says, Alexander was practicing his 10-meter platform dive. Because of gravity, the relation between his height h in meters and the time t in seconds after he dives is quadratic. If Alexander reached a maximum height of 11.225 meters after 0.5 seconds, how long was he above the water after he dove? So here we're not given the quadratic relation. That means we need to model the problem with 1. So I'm going to start by drawing a sketch of our scenario so that we have a visual of the information we have. We have height, which is in meters, and we have time that's in seconds. We know that Alexander starts off from a 10-meter platform at time t equals 0, and then he goes up into the air and reaches a maximum height of 11.225 meters at a time of 0.5 seconds, and then comes back down hitting the water. So from this sketch, we actually have 2 points. We have the y-intercept with coordinates 0, 10, and we have the vertex here with coordinates 0.5 and 11.225. We can actually come up with the equation for this parabola in vertex form since we have the vertex. The vertex form is y is equal to a times x minus h squared plus k. We already know h and k. They are 0.5 and 11.225. They're the coordinates of the vertex, but we still need to find a, so we're going to sub in the coordinates of the point 0, 10, with 0 being x and 10 being y, and then we're going to solve for a. So making that substitution, we get 10 is equal to a times 0 minus 0.5 squared plus 11.225. Now I'm going to evaluate this part. A negative 0.5 squared is equal to 0.25, and I still have to multiply by a, and then adding 11.225 at the end gives us this line. Next I have to get 0.25a by itself, so I'm going to subtract 11.225 from both sides. And 10 minus 11.225 just gives me negative 1.225. And then the last step is to get a by itself by dividing both sides by 0.25, giving us an a value of negative 4.9. So that means that the equation that's going to model this problem will be y is equal to negative 4.9 times x minus 0.5 squared plus 11.225. Now, I'm using y and x here, but they can be replaced with the variables in our problem. So y is going to be replaced by height, or h, and x is going to be replaced by t. Okay? And here we're asked to find for how long Alexander was above the water. So he was above the water from 0 seconds when he left the platform up until the time he reached the water. So if we know when he reached the water, we'd be able to answer that question. So in order for us to figure out the time, we're going to sub in 0 for the height, and 0 represents the water level. And now we have a quadratic equation that we need to solve. Since this right-hand side is in vertex form, the best way to solve this problem is by isolating t. So I'm going to follow BEDMAS backwards and undo all the operations performed on t. So we have here exponents, we have brackets, we have multiplication here, and addition. So the first thing I need to reverse is the addition, so I have to subtract 11.225 from both sides. So that's done. Next, I'm going to reverse the multiplication. So the opposite of multiplying by negative 4.9 is dividing both sides by negative 4.9. And that gives me an answer of 2.291. Next, I'm going to take the square roots of both sides. So when I take the square root of this side, I end up with t minus 0.5. And the square root of this side would give me two answers. When I take that square root, I get 1.514. And now I'm going to separate these into two linear equations. So t minus 0.5 could equal to positive 1.514, or t minus 0.5 could equal to negative 1.514. Okay. Solving the first one, I'm going to add 0.5 to both sides, giving me a time of 2.01 if I round to two decimal places. And this one, if I add 0.5 to both sides, gives me an answer of negative 1.01. So that means the diver is going to be above the water for 2.01 seconds, because this answer here doesn't make sense. We're not going to say the diver is in the air for negative 0.01 seconds. We can't have negative time. So this answer doesn't make sense in the context of the problem, even though it satisfies the equation. So therefore, Alexandra was above the water for 2.0 seconds. Okay. And now for our last example, which is on page 355. It says statisticians use various models to make predictions about population growth. Ontario's population in 100,000s can be modeled by the relation p is equal to 0.007x squared plus 0.196x plus 21.5, where x is the number of years since 1900. A, using this model, what was Ontario's population in 1925? And B, when will Ontario's population reach 15 million? So let's start by answering part A. We want to find the population P when the year is 1925. Since X represents the number of years since 1900, we're going to sub in 25 in for X and evaluate. And that gives us 30.775. Now remember, this is in 100,000, so if we take 30.775 and multiply by 100,000, we'd actually get 3,077,500. You can just move this decimal place 5 places to the right, 1, 2, 3, 4, 5, and fill in the spaces with zeros. So therefore, the population in 1925 was 3,077,500. Okay, now for the next part of the question. Here, we actually want to know when the Ontario's population will reach 15 million. So we have to figure out what 15 million is in 100,000s. So if we take 15 million and divide by 100,000, we'll see that here I'm just canceling all the zeros, leaving me with 150. So there's 150 100,000s that make up 15 million. So this is the population, and now we need to solve for X. So we're going to sub in 150 for P. which gives us this quadratic. In order to solve this, we're going to make one side equal to 0. So we're going to subtract 150 from both sides. And then combining my numbers there at the end, I get negative 28.5. Okay, I see that the right side is in standard form. So how would I solve this? Well, factoring would be difficult with all these decimals, and it might not be factorable. So I'm going to use the quadratic formula to solve this. So from here, I'm going to state the values of a, b, and c. A is the coefficient of x squared, which is 0.007. B is the coefficient of x, which is 0.196. And c is the constant of negative 128.5. Okay, now I'm going to write the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to sub in the values. Now I'm going to simplify. So I'll get negative 0.196 plus or minus. If I evaluate this part under the square root sign, I'll get 3.64. And 2 times 0.07 is 0.014. And now I'm going to solve for x by adding the square root of 3.64 and by subtracting the square root of 3.64. So when I add, I get an answer of 122.28. And then when I subtract, I get an answer of negative 150.28. Okay. So the negative represents the past, and we want to know what it is in the future because from the graph that was shown, the population in 1900 was above 15 million, and the model is only valid for the population since 1900. So if I add 1900 to 122.8, I would get an answer of 2022.28. So I'm just going to use a whole number of 2022. So finally we can write a therefore statement. Therefore, the population will reach 15 million in 2022.